I'm Jasper Brian Esquiapo, responsible for the research problem and background, significance of the study, and research question and hypothesis. Artificial intelligence has grown significantly in recent years, driven by the need of innovation, efficiency, and automation. Without a doubt, the aviation industry will pick up this technology, hoping to decrease its workload. The performance that the artificial intelligence has shown throughout its debut has demonstrated incredible reliability. Significance of the study provides the data for the potentiality of AI systems to replace human pilots, focusing on commercial aircrafts. The findings will benefit the following: airlines, aviation regulation, commercial airline passengers, and of course, future researchers. Moving on to the research question and hypothesis. The general question to be answered are: how does the perceived ability of AI to handle unexpected or emergency situation compared to that of human pilots? What is the level of trust in AI system compared to human pilots among airline passengers? And lastly, how the perception of flight safety differ between AI operated and human piloted commercial aircraft? And our hypotheses are: null hypothesis is artificial intelligence does not serve as a replacement for human pilots in commercial aircrafts. And our alternative is artificial intelligence can serve as a replacement for human pilots in commercial aircrafts.
Hi, I'm Sean Jaden Rivera. Today, we propose our title research, the potentiality of artificial intelligence as a replacement for human pilots in commercial aircraft. And here's the RL or related review literature. The study conceptual framework is grounded in human autonomy, teaming or HAT, where an artificial intelligence or AI system operates not to a replacement for pilots, but to cooperative teammates with a high agency. The commutativeness and evolving shared mental models that ensure independence between human and machine. Underpinning this collaboration is human-centered design or HCD, which emphasizes usability, operational, and explainability, and the preservation of human agency and oversight in a AI piloted interaction. And here's the another one. To mitigate cognitive or vulnerability such as automation bias and skill degradation. The framework incorporates flexible level of automation or LOA, including both adaptive and adaptable automation approaches that allow dynamic shift in control based on workload, situational awareness, and human readiness. Together, these elements and a multidimensional framework to compare the effectiveness, safety, implementation, and resilience of a AI augmented versus traditional pilots operation in commercial aviation. That's it.
Research design. This study will use a quantitative research design which provides a structured framework for collecting measurable data and testing hypotheses. This method is built for experimental studies requiring objective and verifiable results. Quantitative research systematically collects and analyzes numerical data through observations, surveys, and experiments, ensuring reliability and generalizability and statistical testing. This approach simplifies complex issues and allows controlled experimentation and objective evaluation of the material or system's performance. Quantitative research ensures precision, accuracy, and replicability, enabling future researchers to duplicate results. Participants and sampling procedure. This study will compare AI-based flight systems and licensed commercial pilots in commercial aviation. AI system will be used for piloting tasks while licensed pilots will be used as a benchmark. Data will be collected through simulation, outputs, performance reports, and test scenarios. The study will use a purposive sampling procedure, selecting respondents based on qualification and relevance to research objectives. Only licensed commercial pilots with a minimum number of log flight hours will be considered for the pilot group. Data will be collected under various flight conditions, including routine operations, emergency scenarios, and unexpected challenges to ensure comparability and validity. This method will strengthen the accuracy and reliability of the findings.
I am Arkinjadrek Aroque, and I will be explaining the research instruments and the data gathering procedures. For the research instruments that were included are questionnaires and structured interviews. Since the researchers are conducting a quantitative research in which it is mostly focused on numerical data and objective data, the researchers concluded that questionnaires and structured interviews would be the best research instrument to use. Next, we have the data gathering procedures. As the researchers have decided to use questionnaires and structured interviews, it was mostly carried out using online platforms. The questionnaires were made on Google Forms and were then shared through online platforms like Messenger, Instagram, and Gmail. The same were done for the structured interview questions. They were also shared through Messenger, Instagram, and also Gmail.
The study's conceptual framework is grounded in a human autonomy teaming paradigm wherein artificial intelligence AI systems operate not as replacement for pilots but as cooperative teammates with high agency, communicativeness, and evolving shared mental models that ensure interdependence between human and machine. Underpinning this collaboration is human-centered design, which emphasizes usability, operational explainability, and the preservation of human agency and oversight in AI-piloted interactions. The framework recognizes the ironies of automations where increased automation can paradoxically erode human skills and vigilance, prompting need for systems that support adaptability and readiness for rare critical interventions. And complementing these considerations, the framework integrates the Shell human factors model, capturing interactions among software, hardware, environment, and labor to account for contextual and systematic factors influencing performance to mitigate cognitive vulnerabilities such as automation bias and skill degradation. The framework incorporates flexible levels of automations, including both adaptive and adaptable automations approaches that allow dynamic shifts in control based on workload, situational awareness, and human readiness. Together, these elements form a multidimensional framework to compare the effectiveness, safety implications, and resilience of AI augmented versus traditional pilot operations commercial aviation.